All right, here's some few comments I had on data analytics. Um, the previous was sort of on the whole data science process. What the process involved was from going from data to data to information to knowledge to wisdom. Part of that process is the actual analytics of actually running transformations and filters. And this slide here from another one from Davenport points out that when we go to analytics, we can compare what's involved with big data and small data. And how do they compare? So obviously, you can do a small data problem with internal data, your own data, then you generalize to other people's data and we'll get a lot bigger. Another possibility is the big data is actually the important data, and the small data is what's often called the metadata, the control data, the data that tells you what the big data is about. And you need to have good relationships between the people doing this. And this is more a business analysis. I don't think in science you see this issue. We don't have product managers and customers. Well, we do have customers in science, but we don't really have so often product managers and internal managers. And here's an important comment about the technologies. I've noted before that the NoSQL technologies, such as MapReduce, Pig, and Hive, I wouldn't put Python in the same brackets as them because Python is a language. Hadoop is a programming model which is particularly optimized for large data. It is chosen often over databases because, as I mentioned, Hadoop can do data center scale analyses. SQL and databases tends to do smaller analyses, which are often quite sufficient. But if you need to run 100,000 servers at the same time, you'll probably find it easier with MapReduce and Hadoop and NoSQL than you will with databases. So here's some general comments I once wrote on data analytics and actually Informatics and even the whole process of data science, that this is a field which is still immature. You can see that we had all these different definitions of what the process is, and some are conflicting views of what's important. That's inevitable in a field that's just getting started. And there is, although I've talked about data analytics and data science, there is no agreement as to consensus as to what this is, or even if it exists. Especially whether data science exists, because somehow data science is a field. Usually if you have something like some computer science, that is the science of studying computers. Data science is presumably the science of studying data. So I would say it's somewhat controversial, and well, let's say it's not terribly controversial, but it's unagreed as to what that is. We have these choices we've already mentioned, like not only SQL, NoSQL versus databases. We have this issue as to where the computing is and where the data is, and also whether that data is shared or whether each individual has their own data. If we have shared data, namely repositories, the actual architecture of that, whether the data is separate from the computing and things like that, is important. There's this principle which we'll come back to of bringing computing to the data. That points out that the data needs to be transformed. If to do the transformation, we have to move the data from where it's stored to a computer, run the transformation, then move the data back. You may actually be dominated by the data movement step, and that may not be the most effective. If you look at how Google and Yahoo and Bing and people do their web crawls, that web crawling data is stored on disks of computers, which is the same computers which are used to answer your query. So that's a very clear case where a very large application, the computing is brought to the data. The data is not stored away on some repository, and then when you query it, it's sent to the computer. You will not get your query answer back in a tenth of a second or whatever's required if you have to move the data to the computing. We have different sources of data. Some of it comes from experiments, some comes from simulation. An important source of data is actually other computers producing data. We have these different terms: data analysis. That's what I used to call what I did. Data mining. That is sort of got a connotation that you don't know what you're looking for, and you're doing an exploratory examination, and that's sort of a growing trend. Data analytics, that's somehow a cosmic term. Machine learning is sort of pretty similar to data analytics. And another important component is looking at the results, that's information visualization. All of this requires several fields. I discussed chopping people's heads up so that each part of the head knew about things. So we have informatics, computer science, the library and information science. These are the free fields at the present at Indiana. Statistics, of course, is also at Indiana in the College of Arts and Sciences, and we have important application fields. Um, Another important issue is the big data versus little data. We had a slide from this on this from Davenport, but a good example is, say, social science. Traditionally, that used to be dominated by what's called ethnography, surveys, and interviews. But nowadays, some people are looking at very different approaches, taking large scale data, say, going to cell phone companies and getting the data on interactions of people, or even just going to Facebook and things like that. And that is doing social science analyses. And whereas, with ethnography, you'll probably find it hard to do more than 20 interviews on a subject. You can have a billion cell phone interactions. And the trade-off between these different approaches is important. There are also a lot of sort of cosmic things you need to worry about. Your data, you has to have security. It needs to have provenance, telling you where the data came from and how it was processed. That's an example of metadata, data about data. We need to manage the data, put it into databases automatically or not so automatically, add metadata, and we discuss curation, the fact that the data needs to be cleaned up. So as well as the flashy analysis, getting the brilliant conclusion, there are lots of important aspects of data science.